In recent years, the city of Oslo was struggling more and more with heavy torrential rains, causing floods on city streets. Triggered by these events, they went for an experimental project of water retention. In 2017, 2 streets were realized as test locations. The idea was to create rain gardens, which act like a sponge. When it rains, the water from roofs and roads doesn't flow directly to the city drainage. Instead, it's first being absorbed and held on the street. Thanks to this buffer, regular storm drains aren't overwhelmed even during heavier rains, and the street doesn't flood. This unordinary project is located on 2 ordinary streets in central Oslo, Deichmans Gata and Wilses Gata. We are looking on Norway's very first integrated stormwater system in urban settings. So let me tell you something more. What is this? Normally, traditional cities rely on underground pipes to handle rainwater. But during extreme weather, that doesn't always work well. I mean, during those huge torrential rains. The rainwater flow goes something like this. The rain falls, water goes into drains, and the last time we see it is when it disappears in underground pipes. From here, it travels further into a river, sea, or to a treatment facility. This normally works as it should, except, well, sewer systems are often designed for past conditions. New houses and more impermeable surfaces bring some more water to handle. With climate change, the rainfall intensity is going a bit stronger. So for the system, becoming overwhelmed is a bit easier. The result? Streets are flooded. So one day, when drainage capacity is no longer enough, cities face a choice. Shall we change pipes to bigger pipes? Or shall we reduce the amount of water that enters the pipe system in the first place? Deichmans Gata is an experiment in reducing water in the pipe system. In other words, retaining water on the surface. This project spreads rainwater across the ground and lets it infiltrate locally. The core element is a series of rain gardens. Imagine them as shallow basins with plants. They are the sponges. They collect, absorb, and help evaporate the rainwater, slowing the flow and reducing the amount of rainwater entering the drainage system. There are 9 rainbeds across these 2 streets. Together they can handle around 60 cubic meters of water. Plus, there are some permeable areas only for water absorption, without the capacity to store it. Here is what happens when it rains. Water flows from roofs and paved surfaces into rain gardens. Here it first infiltrates into the soil. Once the ground becomes saturated, the excess water is temporarily stored in rain gardens basins. In case of heavy rainfall, if the rain garden's capacity is exceeded, the water is redirected further downstream to the regular city drainage system. So instead of one pipe doing everything from the beginning, there is now a decentralized system across the whole street. There is this 60 cubic meters rainwater buffer before the city drainage network is fully used. And during heavy storms, this makes some difference. Rainwater retention is managed through a 3-step strategy. As rainfall intensity increases, additional measures are activated to handle larger volumes of water. The step 1 is everyday rain. About 95% of all rainfall in Norway consists from small frequent events. These can be handled directly on site. Green roofs, permeable surfaces, like you can make pavement tiles permeable. Small rain gardens, all of these absorb and use the rainwater locally. This is the most efficient layer because it deals with most rainfall directly where it falls. Step 2 is heavy rainfall. For larger events, like a big storm that comes once per 5 to 50 years, the system needs more capacity. Measures at this stage are designed to temporarily store water. They ensure that the stormwater is retained locally so that municipal sewage network and local water courses are relieved. This function can be provided by valleys in green areas or by underground tanks. Or even rain gardens on streets can handle stage 2 if they are designed to store water in a flood situation, so they are shaped like basins. As the rainwater buffers fill their capacity, the water is slowly released also further to the regular city drainage. And the final step, step 3, is extreme events. For rare extreme rainfall, there should be safe paths for overflow. Water is directed along streets, waterways, ditches or canals, away from buildings and critical infrastructure. because at this point it's not about preventing flooding anymore, it's about preventing damage. Applying the three-step strategy to Deichmans Gata and Wilses Gata, the designers kept the traditional cable roofs without any water retention measures. Instead, they relied only on rain gardens, which work both as a step 1 absorption and step 2 storage. In more extreme events, the water overflows into the regular underground city drainage system or flows through the streets. On paper, rain gardens might always work, but in reality, in some parts this project didn't really work as expected. The research and development brochure from Asplan Viak, that's the company behind this project, reveals more. The link is in the description. It's in Norwegian, but you can translate it with an online translator. So here is what didn't quite go according to plan. Certain inlets were poorly designed, so water bypassed the system. Specifically, some rain gardens were able to withstand a 200 years flood, but the inlets were not able to deliver such a large inflow of water. So a poor inlet design did reduce the overall capacity. In this video from the testing day, you can see the barrier they had to create at the drainage channel in order to direct water to rain garden. Or other issue, some rain gardens were not 100% flat. This made the infiltration capacity smaller. Water could be already overflowing on one side, while on the other side it had barely reached the soil. The other observation, the edges of rain gardens are quite vulnerable. The vegetation here can be easily damaged by trampling or by peeing dogs, so the project should keep this in mind. The other one was that the rainbeds actually don't always receive enough water to function properly. One might assume that plants for wet environments might be the best choice here, but in reality, rain gardens are most of the time dry. So that should be reflected also in plant selection. The other observation was that when people walk on rain gardens, the soil becomes way too compacted, which reduces the infiltration. So walking on rain gardens is a no-no. And what you should have in mind is erosion at the inlet. This can be reduced by using river stones, which take some of the energy out of the water before it reaches the rainbed surface. So the lesson from this was that these systems can be quite sensitive. Even small design and construction mistakes can disrupt how they work. But luckily, many of these issues are relatively easy to fix. Already rushing outside to dig your own rain garden? Hold on for a second. Let's first get an idea what to put inside one. So, in the rain gardens there are multiple layers of soil and gravel. Each has its specific role, from filtering to storing to guiding water. On top there is a filtering medium. It consists from a 1-to-1 mixture of organic matter and sand. So it serves as a substrate for plants, but also for absorption of water. For rain gardens that require drainage, there is a drainage layer at the very bottom, which surrounds a drainage pipe. This is often the case of dense urban areas with poor ground conditions and the lack of control where the infiltrated water is going to end up. The water can follow existing trench and pipe routes underground and create various problems, so instead of storing it, it's better to drain it away. Between the drainage layer and the filtering medium, there is a transition layer. It prevents fine masses from the filtering medium from being washed down into the drainage layer. On the very top, there is a space for water accumulation. Since standing water deeper than 20 centimeters is associated with a risk of drowning, at least in Norway, this should be also considered. And one more detail, when water enters the rain garden from the road, it passes through a sludge pocket. The runoff may contain organic pollutants, heavy metals or a lot of garbage that is not welcome in the soil surface, so it gets trapped just here. This system achieved infiltration rates of around 24 centimeters per hour, which is well above Norwegian recommended levels, and those ones are around 10 centimeters per hour. And for the next level of rain garden, check this upgraded version. In 2 of the rain gardens, delay cassettes were installed for experimental reasons. These cassettes are hidden storage units, which work as underground reservoirs. When the rain garden fills up, the excess water is directed down into these chambers, where it's temporarily stored and slowly released. compared to a traditional gravel layer. These cassettes provide much more empty space for holding water. The trial showed these cassettes were able to almost withstood a 200 years flood, because the cassettes were able to quickly transfer excess water from the surface to the storage. Stormwater retention reduces pressure on sewer systems, and it also stores water in the soil, helping plants and trees survive dry periods. But it's not just a purely functional infrastructure, it also makes the street much nicer. These rain gardens are planted with perennials, often flowers, adding greenery to the street. Inside the gardens there are stepping stones and some water elements, places where kids can play. So instead of keeping the street asphalted, you make it more green. As a bonus, this provides some cooling in warm summer months. And the trade-offs. Let's be honest, this approach is not for free. Parking spaces were removed. Yes, that's true. And there are other constraints. Maintenance is required. Design complexity is higher. Small errors can cause whole system to fail. So this is a multifunctional investment with its price. And in the end, instead of hiding water underground, you can make it part of everyday life. For kids, part of joy. These two streets are a prototype, a test whether cities can move from hidden centralized infrastructure to systems which are visible, distributed and more resilient. Systems that bring some more green and joy to our streets and don't bet it all on one pipe, but spread the risk instead.